Today I thought we'd talk about bandsaws a little bit. Here I am surrounded by bandsaws from fairly large Tanowitz saw over here to diminutive Ryobi. I got a thoughtful question in the comments section, and the gentleman was talking about blade guides for the bandsaw. And so I kind of wanted to talk to you what I think is up with blade guides and how best they can control the blade, because they're a big part of bandsaw setup. Having said that, pretty much everything about a bandsaw is set up. It's such a simple machine. You could think of it kind of as a bicycle where one wheel is driven and one wheel is steering. And it's pretty much the same kind of thing. In fact, any bicycle would make a serviceable bandsaw if you played around with it a little bit. Really, the whole thing is about guiding the blade, getting the blade stiff enough by elongating it. And, you know, we have ways of doing that we'll talk about in a little while. So you stretch the blade in order to increase its stiffness and its ability to stay straight inside the cut. Well, let's start with the smallest saw first. This is easy to get at your local store. I think they're $220 at Home Depot. They come with this lightweight plastic miter gauge, which is, I guess, of some use. But it's a pretty good saw. It's got cast wheels, and it has nice gummy tires, and it really is a beautiful little thing. I mean, the only real disadvantage is that the wheels are so small diameter that they curve the blade quite a lot, and that tends to reduce the life of the blade. But since those of us who build guitars are using bandsaws for very specific things for short periods of time, we're not going to worry too much about longevity with a little buddy like this. On this one, you can see that it has 3 components to the blade guide system. There's a piece of steel on each side of the blade that's adjustable and clamped by these little set screws here. And that's supposed to, gee, it looks like these could be a little tighter. That's supposed to keep the blade from wandering in direction. And then, as you can see, there's a bearing in the back, which is the thrust bearing, which has a groove in it on this saw to help position the back of the blade, although the groove seems to be big enough so that it's not really doing much of that. Anyhow, that's how it works. And I think this is a pretty great little system and perfectly suited to the needs of this saw. It works great. Now, you see that I have this block of wood up on here, and this is designed to raise the table surface up. Just thought I'd point this out so that if you're doing something like this, you'll be able to get your hand underneath the work and guide it precisely and have more control over it than if it were just sitting on the table. So this is a really nice thing to do, and it's also insensitive to curvature the way the table is. In other words, if you have a piece like this that has an arc shape on the bottom, because the surface is so small, you'll be able to get support right next to where the blade is cutting and not have any trouble at all with vibrating or getting out of control because the blade is moving the wood too much. Anyway, handy little thing. I've got a bunch of these. Nothing fancy. Here's some more. Here's one that's got a little bit bigger surface. Anyway, they're really good, and again, good for safety because you can get your hands underneath, and good for accuracy because you're gonna be able to get a really good grip on it. Let's move to this saw. This is kind of a luxury item in my shop, but I'm really glad I have it. It's made by the KALLL company, which made absolutely fantastic stuff. And you can see over here on the left side, there's a calibrated scale that shows you blade speed. And to the left of that, you can see a handle that regulates the speed of the saw. Okay. So that's with a variable size pulley drive where the pulleys change sizes as you slide them around. Anyway, so this saw is designed to cut metal, and I guess the speeds here are from 75 to maybe a bit more than 450 feet per minute, which is really slow. And, well, here. That's super slow, and that's good for cutting pieces of steel or cast iron or things that are hard to saw. You don't want to move the blade too quickly or you'll build heat. Now, here we have this handy dial gauge here, dial chart that shows you pick a material, like let's say you were gonna saw nickel silver. We know this because frets are nickel silver. It's a copper alloy. It says here 450 to 175 feet per minute, and then how many teeth the saw should have, and these other things, the set and the temper, are kind of the deep end of the pool. And then, interestingly, this saw has also the capability of file. It's a crazy thing. I forgot to pull it out, but we'll stick it in there. We'll poke that in right around now to show you what the file looks like. Very interesting. So it says here, it's a Metal Master, continuous contour sawing and filing. So we'll show you all about that. Anyway, cool thing, helps you understand how fast things want to go. And this is a critical thing in all kinds of machining, in any material, in wood or metal, plastic. The common in my country, we say surface feet per minute. So, it would be meters per minute, or everywhere else, I guess. Anyhow, so surface feet per minute for wood. A lot of things like to see speeds between 5,000 and 5,500 surface feet per minute, which is right around 60 miles an hour. And so that's kind of a normal speed for sawing and also sanding in many applications. Also, a lot of sanding operations also should be going that same roughly mile a minute or 5,000 to 5,500 surface feet per minute. Anyway, that's speed. Okay, so as advertised, I'm showing you the band file option here on the dual contour sawing and filing setup. And you can see that these are some pretty aggressive cutters. Now these they're not flat. There's a little bit of curve across so that they're a little breasted. A lot of interesting things to notice here. There's one continuous piece of spring steel on the inside that, of course, rides on the tire. And then you can see there's two rivets where it's precisely riveted in exactly the right spot. And then the segments in between the wheels will lie together like this and present essentially one long file experience, so it's a continuous motion and not reciprocating the way regular filing is. And then also, I think if you can get a close-up right inside here, you can see that there's a little half-round part on this bottom side. This would be the side that touches first on its way down to the table. And then here's the top side of the one in front of it, and that has a mating concave shape. And so what that does is when they connect and the thing is straight, it tends to keep these things in columns so that they, can't get wibbly and point in different directions. Here's another one that has, this is a ½ inch or 13 millimeters-ish wide, and this is half of that width. So these have a bigger curve. It's a finer cut, as you can probably see. And it still has these little half-roundy gizmos in there to help keep the whole thing lined up. Really an astonishing piece of engineering, almost kind of feels medieval or something. It's just great. And I confess I've had this saw for a long time, and I have never mounted one of these. So maybe someday for a Riff, we'll fire one up and see how it does. Might be pretty surprised. But this would have been very helpful before the days of modern machining, where we have electrical discharge machining and super accurate and capable machines as vertical machining centers and all kinds of things. Hybrid machines now that combine lathes and mills in ways that we only could have dreamed of a little while ago, just now routinely done. So this kind of technology is just not called for anymore, but how cool is this? Come on. This is a Rockwell Delta saw that has a special blade on it with diamond grit. So there's no teeth per se, but there's a coating of diamonds, and you'll see the saw is loose because we don't want to keep it tight when we're not using it. This blade, they tell us, wants to go about 2,000 surface feet per minute, which is way slower than woodworking speed. And so to that event, we have this cool option on the Rockwell saw, which has a gearbox up top. And you can either run the saw direct the way it is now, or to slow it down, you would use the gearbox, which speed reduction gear that you can see right over here, I think, all covered up and full of oil. And then you would be using a smaller belt that would drive this, and then you can see there's also other speed. You'd have your choice of, 4 more speeds in the back gear or low range. And in fact, this saw hasn't been set up to run at 2,000 surface feet per minute yet. This kind of saw, another example of which is right here, has been made for an awfully long time. And it's kind of a brilliant design that everybody else has copied. There's a guy, Mr. Iturra in Florida, who has specialized in these saws. There's a really old one here, probably from the 40s, cast iron base. He has no online presence whatsoever. So if you want to get anything from Iturra, you've got to either call him or write him a letter, and then he'll mail you one of these. And boy, I'll tell you, it's a good thing to have. There's a tremendous amount of information in here. They have a bunch of upgraded components. Here's a carbon fiber insert compared to cast aluminum. Here's one of their products here, which is just a plastic disc, which I like very much. So this is the throat plate, and when they get used, especially if the bandsaw is being used crudely, the throat plate can chew out a lot of material where you wish it didn't. So this is a nice way so that you can get some support of the table surface right near the blade. So yeah, so this saw is something that gets used often in the shop, and it usefully has this very inexpensive, as it turns out, rip fence that you can get from these guys too. I'm going to move on to this little buddy. This is Heston and Anderson. I don't know if you can read this faceplate in here. This is probably, I don't know, 1920, something like that. And in the days of gingerbread houses, so-called houses decorated with fancy bandsaw wooden molding, this saw would have been used on site when they were putting the house together, not to make the molding, but to kind of, modify it, fit it, make an extra piece if you needed to, whatever. Very nice saw. I've had this for a long time, and it's a terrific little machine. I'm going to show you something. This is a tapered pin, and there's a carefully reamed hole here, which has the matching taper, and this taper will help line up the iron table on both sides. Okay. If we look here at the Rockwell saw, we see we've got the same kind of thing. I'll struggle with these guys. Usually just use a claw hammer to pull these out, but that's another tapered pin. And of course there's one over there too. And the job is to help keep the table surfaces aligned, because sometimes the iron will want to warp or droop a little bit. And that can be a little problem. Anyway, so with this out, we can remove the table very easily on this saw. And I'll show you something that I made for this saw, which is pretty useful. And that is a kind of an auxiliary table that'll allow you to cut odd things that are not happy to lay on a table for you. Like, things that are guitar shaped. So this will allow you to cut a piece of purfling this wide. So this will be our fence, this piece of gray PVC over here. Here's a hose clamp to back up its position, so when you push on it, it doesn't slide over. Maybe that happened. Anyway, the whole idea is that you can safely feed a piece of material here and get a little strip, whatever size you want, even if the piece has a lot of undulation and is guitar shaped. So that's pretty cool. I love this little guy. All right. Oh yeah, so back to blade guides. If we look here, we see on the top of this machine, we have 2 pairs of blade guides. And on the bottom, there's only one. Now, it stands to reason that when the saw is running without any load on it, when it's just running in air and you're not cutting anything, you would suspect that the tension of the blade would be equal all around the wheels and in these straight parts in between the tangents. You'd expect that the tension would be equal because the wheels are creating that tension, and why wouldn't it be equal? It would just naturally tend to be equal. But what happens when you actually use the saw, you have a piece of material here, and the saw is being driven by the bottom wheel here, which is pulling down, right? And then, of course, there's all kinds of friction and cutting forces within the wood. So this part of the saw blade, from where it's actually doing the work and where it's being pulled, right here, is going to be under more tension than the rest of the saw blade. So even though you have an added tension, you kind of have by making a point of friction here. So because of the loads that we're seeing on the teeth of the blade, we're going to get some extra tension in this part of the blade. So that stands to reason that the rest of the blade will have a little bit less tension. And I noticed many years ago that when I was resawing, sometimes the upper part of this blade could be seen to flutter and dance around. And I decided I would try and control that by making a little wooden clamp that the blade ran through, and the clamp would deflect the blade a little bit and try and well, at least keep it from fluttering. I don't know if it really raised the tension up here, but at least it would keep it from fluttering. And of course, fluttering is not happy behavior when you're trying to saw a perfect slice of wood from a precious piece of material that you care very much about, like a guitar side or a guitar back or something like that. So anyhow, yeah, so it's important to be thoughtful about what the forces are in the saw during the cut. Well, on any machine really, but on the bandsaw, which again looks so simple and is simple in a lot of ways, there are a lot of little subtleties going on. We'll look at these blade guides, pair here. So this is going to help to keep this top part from fluttering. That's how I got started on the fluttering part. So just having these two pairs of guides separated by the short distance will tend to keep the blade, this top part of the blade, from fluttering as it enters the material, okay? And then on the bottom, of course, it's just one pair of guides. They all do them a little differently. This one has just a hard piece of material, another guide, same as this thing. 8mm rod that's hardened steel. And then, so when this wears, you would just rotate it to get a fresh surface. And then up top, they've used the periphery of a ball bearing to take the load. And that's nice, partly because it presumably will generate less heat. And, you know, heat is not our friend on the bandsaw. For one thing, when blades get hot, they get longer. And then when they get longer, they are immediately less tension than you try to put on. So on a little saw, you use whatever tension you can get from your spring. I don't really measure them on these little saws. If you get it tight, they work fine. I guess I could measure them. Could measure one. We could throw in a measurement. But it certainly is important on bigger blades for resawing. I always measure those. And then one other note before I forget is that, at least in my world, a small saw like this with a 1/4-inch blade, these are 6 teeth per inch. It's my favorite all-purpose woodworking blade. A blade like this, I do not bother lowering the tension overnight or ever, really. The blades give really good service. They're not that highly stressed in tension because, for one thing, you can't get that much tension on them with this, you know, this little hand wheel. There's only so much you can do. And there's a spring up here that you can't see that's inside of this cast part that operates. There's always a spring somewhere up here in the blade tensioning system. So let's look at these saws. We can see here's a tension spring here, and there is a little gauge on it that's designed to help you tension the blade properly for that whatever width blade you're going to use. And let's see here. Anyway, here's some new information for high tension bandsaw springs. I think this one is the original. I haven't installed the high tension one yet. And then this one, this saw over here, which is identical except for the gearbox that we discussed a little while ago. But the operation of the components of the saw is the same thing. On this, we have this high tension spring, which helps us get better tension on the blade. Back to the guides. On this saw, we have ceramic guides. These are ceramic blocks that are fired into net shape, I believe. They're not machined, I don't think. I think these are kind of manufactured in this shape. They're very, very hard and wear resistant, almost unbelievably so. One problem can be that on some of them they chip and pieces can flake off, when that's always the challenge of a hard, super hard crystalline material like this. And then on this Rockwell saw, we can see that we still have the original steel blocks, and I think they're fine. I mean, you know, I have machine shop capabilities here, so I don't have any trouble getting the ends of these blocks perfectly square and smooth. They'll control the blade really as well as anything. And they may not wear as long as these white ceramic blocks, but anyway, so far so good. Won't change your life, I don't think. Anyway, so that's a look at some of the smaller saws. I've got a lot of capabilities here from, you know, this little commercially available Ryobi thing, my old pal variable speed dual, you know, these three saws. These two are really the ones that get used day to day for the most part. And then I'd like to introduce you to the Tanowitz saw. Now this saw was made in 1964. So what, I was 12. And when I was 16 years old, this was the first bandsaw I ever turned on. I was working a summer job at the local woodworking company in Poughkeepsie, New York. And they had a lot of Tanowitz bandsaws. And the department that I worked in had two saws exactly this style and size. Pardon me, four saws. They had four saws in a row with big hydraulically controlled tables that operated like this and were automatically controlled. Before computers were controlling things, they were just controlled by logic hydraulic control. So there'd be a switch, a hydraulic switch that would get bumped, and it would close a valve, and the fluid would go do one thing, and then it would get unbumped, and the fluid would do another thing. Not so different than what we do now, but no computer brain, just a logic control. Anyhow, so this saw is coming up on 60 years old. It's in great condition. Table's a little worn, but not bad. It has a 7.5 horsepower motor, which is a thing of beauty. One thing I didn't understand about this saw when I bought it was that this motor has been rewound. And when they rewound the motor, they didn't include the low voltage option. And so when I bought the saw, I thought I could run it on 220 volts, but it turns out that that option was not reinstated by the people that rewound this motor. And so it needed 440 volts in order to work. So we had to buy a transformer and play some games. Anyway, there it is, 7.5 horsepower. And I believe the speed of this of the motor is 690 RPM, which is kind of a head scratcher of a speed for an electric motor. I don't know why it's like that or how they did it. Well, here's the motor faceplate, and you'll see it clearly says that there's dual voltage. That shows you how to wire it for lower volts and higher volts. But like I said, the people that rewound it disabled that option, so it's only going to run at high voltage. Yeah. So direct drive, no belts, nothing to go wrong. The bottom wheel hangs right off the motor. And there's a whole, I'm not going to get into the whole thing, but these saws were innovative in some impressive ways. And one of them is the wheels. You'll notice that a lot of bandsaw wheels are cast, and these are not. These are spun from very thick sheet steel with internal reinforcing components, etc., to make a very, very strong and stable wheel assembly. And then you can see around the perimeter of the wheel, there are threaded holes. There's these bushings with threads in them for big bolts. And those are used as kind of the reverse of a gear puller to press the tire onto the wheel. Unlike every other kind of bandsaw, the Tanowitz saws have a special engineered tire, which is a rubber and steel composite construction, which are already precisely sized, trued, and balanced at speed. And this saw was designed to run at 7,600 feet per minute, which is quite a bit faster than the 5,000 or 5,500 surface feet per minute that we're normally aiming at. And in fact, these were sold as high-speed saws. In other words, they were suggesting that you could get more work done because the blade was moving faster. For our purposes, we are using a top quality variable frequency drive that will allow us to change the speed of the motor without losing torque, which is awesome, and means that we can run at any surface foot, any blade speed we want, really. And then, a quick look at blades. These are kind of roughly the limits of what you could put on a saw like this. Here's the blades we were just looking at on the little saws. My favorite blade, my favorite 1/4 inch blade anyway, which is a 6 tooth per inch blade. These blades have induction hardened teeth. So it's one piece of tool steel, and then the back, the silvery colored part, is just left at spring temper as rolled. And then the front part of the blade, where the teeth are ground, is hardened electrically with some resistive gizmo that makes the front of the blade a lot harder. in the back. Something that's been done for a long time. It's a great way to make a bandsaw blade. So, and then this other large blade here, this is 1 3/8 this dimension here. So it's a pretty big blade. These were the size blades that I used when I was a teenager to cut balsa wood. But we not only cut balsa wood, we also, a couple times a summer, would send everybody home except for me and one other guy, and we would saw up Brazilian rosewood and ebony for the guild company. So we would get logs, these lumpy, weird, ancient logs that you couldn't pick up by yourself. And we had a special carriage that would let us saw them into thin slices for fingerboards and bridges. That was my first summer job, was resawing ebony and Brazilian rosewood. So here are the guides that fit the Tanowitz saw. They're supported on a 3/4 inch or 19 millimeter shaft, substantial steel shaft. This one has a big groove in it to help keep it from rotating when it's put in place. And these guides, I believe, are the ones that were supplied with the machine. If they're not, they're identical to them. I remember these vividly from being 16 years old. And these, I think, are probably my favorite saw guides of all time. So here's why. First of all, like the Heston and Anderson saw, we have 2 pairs of support, 2 pairs of blade guides. And both the top and the lower guide they're identical parts. So there's 8 guides instead of the usual 4. And then you can see that the thrust of the blade is taken up by this substantial sized ball bearing. So here's a used one, which you can see why I'm not using this one. So there's a bearing inside here. This is a hardened casing that they press on, and of course a soft shaft. You can see the marks in the shaft. But when I put these together the other day, I took the trouble to machine a flat in here so that we won't have these marks on the shaft, which these make it hard to adjust precisely. And they lead to frustration. And in a regular shop, frustration is often taken out with a hammer. And both of these guides were riddled with hammer persuasion marks. No hammer will ever hit these guys again, as long as I have anything to do with it. And so I took the liberty of cleaning it up in the machine shop and straightening out the surfaces. It's just such a great system. So here's the handy dandy dial that gives you control over the space in between the guide blocks. And when you've gotten to the space that you want, which you can safely change this space while the saw is running, which is not the case for any of these other saws. And it's one of the reasons why I think this is such a great design. So you can go ahead and fine-tune the grip that this kind of adjustable pairs of guide blocks are applying, so that you get it exactly how you want it, just as close as you can possibly get it. Then you shut the saw down and you tighten these screws, and those screws bear on the ends of these rods which go in here. So in effect, it locks the adjustment that you've created in place. You can power the saw back up, make sure you have what you want. If you don't like it, you back out these locking screws on the left side, put a little bit more adjustment to narrow the gap, and then retighten. So there's a little bit of playing back and forth, but that's how you get exactly what you want. Now, when you have exactly what you want, you have a huge amount of support for the blade, and you also have the heat has twice as much stuff to absorb it and radiate it. So the blade guides will be cooler. One of the things that I got to support this saw, which will be used mostly for resawing precious old stuff, is a misting machine, which is called a micronizer. What the micronizer means that you get to distribute a liquid, either a lubricant like oil or a lubricant like water, either of which would also help to cool the saw blade. So this is a little gizmo. So this is gonna spray, I guess right up on top of this top blade guide, we'll use water with a little bit of additives in it to help it make it a little bit slipperier, but it'll mostly be used to cool the saw for resawing difficult and precious materials, like tree material or ebony. Anyway, I can't tell you how happy I am to own this saw, and we've done a lot of things to get it ready to run, and that's going to happen soon. And I'm looking forward to showing you the results of our resawing. Throat plates. So here's the one that came with our saw. We got a few of these, so those will be helping us get support near the blade. You can see down here that this cover is cut off here, and that's because this saw was designed to sit on the floor here, and this part of the saw would go down underneath the level of the floor in order that the operator would have a table height that's more comfortable for most of us, instead of this tall table height that we have here. Actually, I think it's great, but a lot of people think it's too high, and the company designed this saw so that you had to cut a little chunk out of your floor in order to bring the saw into your shop. So, I don't know, maybe we'll use a pallet, or we'll just forget about it one way or the other. Anyway, I feel like I want to ask, are there any questions? But I know some of you are going to be writing in and asking them, so fire away. I guess something most of us don't think about ever, really, but that we could think about a saw like this as being a right-handed saw. So in other words, the cutting part of the blade is on the right hand of the saw when you face it, and a right-handed person would probably be more familiar with coming in over the table like this with their dominant arm. However, some saws, not very many, are arranged left-handed. And here's kind of a cute old example of one of those saws. So this is, I don't know what the provenance of this guy is. This thing is funny in that it's, there's not a maker's mark on it. It doesn't say anywhere anything in letters or numbers, or I can't find it anyway. I don't see any indication that it ever had a name or any other identifying mark. You can tell by how it looks that it has seen some wear, so we know it was used. And you can, just since we've been talking about the blade guides, might as well look at these little goofy guides. These have these kind of nice old pattern wing nuts here. I mean, thumb screws, I guess they are. Thumb screws. With a cast iron washer, if you believe that. And then these are some kind of wooden material. I don't even know what they are. Looks like somebody made them. And anyway, so these are wooden blade guides sitting there. And this one has a a non-working frozen bearing up on top. That won't be fun to change. This came into my possession quite a while ago, and I thought, well, it'll be a fun project for somebody that in my community wanted to do a little something in my shop. And so let's put this back together. But it never happened. And so here it is taking up room that it's not entitled to. So this is going to have to go somewhere else. But anyway, it's kind of cool. Look at this. So your throat plate you can just make up and slide in. And instead of a pin, they've got this. This is comes out like a kind of a jackknife to align the table. So in order to change the blade, you've got to, of course, slide this into a different position. And then let's see, what else have we got for features? Oh, it's just kind of cool, you know, cool blade height adjustment. It's good though. And tension. And then oddly, the tracking gets played off between these two screws. So tighten one, loosen the other. There's our little bandsaw journey for the day.